My name is Bert Jansen. I'm a senior service engineer inside the customer engineering organization in SharePoint and OneDrive. And in my day-to-day role, I do talk a lot with ISVs, with customers, and throttling is a common topic. It's like, I think, 1 out of 2 calls, throttling somewhere pops up and we have to talk about it. So before diving into the technical demo around rate limit headers, I would just want to step back and say and demystify SharePoint throttling a bit, helping you understand how it works. As already in the introduction really explained very well, like, why do we need throttling? We need throttling to ensure that not one particular user, one particular application is not jeopardizing stability for all the other tenants inside an environment. So, because we share resources with many tenants, we have to have a fair use policy, and throttling is our way to achieve that. Okay. All right. So imagine you have a funnel, which you see over here, and your request comes in. What will happen? The request comes in, then your request, for the most part, request is tied to an application. So if you have an Azure AD application and using that application, you make a call to a SharePoint API, you're on this bucket, in this application bucket. And this applies for both delegated and application permissions. A request can also just have a user linked to it, or both. Request, if you use delegated permissions, your request is coming via an application, but we also know who the user is. Most common approach is this application model here. And the first measure we have is number of resource units per app per minute. And this is a pretty common reason of throttling. So what that means is that your application can execute a number of resource units per minute, and if it goes beyond the threshold, it will get throttled. We'll explain later on what it means, those resource units. So, but it's like a first measure. Going further, we have the similar measure, but then for like a day. So if your app is doing too much across a full day, then it can be throttled as well. Quite seldom, but it can happen. So these are the more common approaches for getting throttled. On the left side, for the user here, if your request is tied to a user, either being a delegated permissions or just being like a SPFX web part making a call to a REST endpoint, then we also measure how much user requests happen in a certain time window, and if that goes beyond the threshold, that can lead to throttling as well. Again, quite rare. Then finally, there is some farm level spike protection in place just to protect the resources. Very rare that you get throttled by this one. Eventually, your request comes here. We need to, and in most cases, almost all cases, it's green. Your request happens, and you're good to go. You get your data back, and you can issue the next request. If you get throttled, you're not so happy, but throttling is a common concept and it's easy to deal with. You get either a 49 or 503 HTTP error. You catch those exceptions. There is a retry after header telling you you have to wait for like X seconds, 10 seconds, 20 seconds. So you wait and you then just retry the same request again. So, and then you're good to go. So this is how it works. Now we use those resource units. We talked about that previously. Resource units is our way to document what your application can do before it gets throttled. And the number of resource units an application gets is depending on the tenant size. So the larger the tenant is, the more one particular application can do. So the 50K tenant, you get 6,000 resource units. A small one, you get 1,200. And it's per minute. So we have a bucket of 1 minute, and all requests in that minute, if you don't exceed this quota, you're not throttled. If you exceed, you're throttled. Furthermore, those resource units, they are translated to requests. So like you do a request and a request can be a CSOM request, a graph request, a SharePoint REST request. All these requests are kind of checked and possibly throttled. Though the graph requests are kind of more favored in this model. So if there's a graph equivalent over SharePoint REST or CSOM equivalent, then you should use that. It's more favorable when it comes to throttling. For the graph side, so we have actually defined all the calls, and you can kind of translate your request into resource units. So if you do a delta request with a token, that is just one resource unit. If you do expander permissions, that will count for 5, because that's a really expensive call for us. Overall, I think the best guidance is to just assume 2 resource units per request. So if your app does 1,000 requests, that means 2,000 resource units on average. That also then applies to SharePoint CSOM and REST. So that's an easy way to calculate that. Moving on to rate limit headers. So you've now learned when you get throttled and why you get throttled. Now, throttling is not a good thing. Well, it's a good thing to protect the service, but you don't like it in your application, because when you get throttled, your application kind of gets to a stop. And for that, we've recently introduced a new concept called rate limit headers. So rate limit headers are response headers. So when you do a request, you get a response back. That response contains 3 new, can contain, just to be clear, 3 new headers. A rate limit dash limit, showing you what's your capacity that you have, and like the 1,250 of the 1,200 for a small tenant. If you have a big tenant, it will be 6,000. So how much can you consume? Where are you? How much is remaining? So in this case, there's 1,200, there's 120 resource units remaining. And finally, the reset header, it will tell you like, okay, when will this 1 minute time window expire? And I again start with a new set of 1,200 resource units. So we give you this information, and then you can use this information to start slowing down. The idea is that when you're about to get throttled, let's say you're at 90% of consumption of your resource units, then you maybe want to do a little pause, so to avoid getting throttled altogether. One more thing is that those headers, if you start testing this and you maybe don't see those headers immediately appearing, and that's accurate and normal, because those headers only appear when you are above 80% of your allocated quota. So if you don't see the headers, you're all good, you can keep going. If the header starts to appear, and then you need to act on them. Now you might wonder, like, okay, but why should it do all of this? What's the value for me dealing with those rate limit headers? And for that, I've made this graph over here, where you see a number of requests over time. So let's take a graph when you're not using rate limit headers. So your application, you launch your application, it kicks off like 5 threads, 10 threads, all those threads, they start hitting SharePoint, and you keep ramping up, and everything goes well. At a certain point, you get throttled, and then you get to more like a flat line. Your application gets fully throttled, and it has to wait until all the throttles kind of expire, and you're good to go again, and then you see this ramping up again, flat line, ramping up, flat line. So you really get those kind of stops in the application. If you would use rate limit headers, the green line, you start at the same speed initially, but then whereas the throttling would kind of get you a full stop, rate limit headers will slow you down a little bit, but you don't fully stop. Then you pick up again because you're in the next minute. Again, some small delay because you're delaying some of the requests, full speed, delay, and so on. The good thing is that this gives you extra throughput. And the reason why is because you avoid getting throttled, and that just saves requests. If you get throttled and you try again, then you do 2 requests, not 1. So you do 2 requests against a particular quota that you have. So the more you get throttled, the more you kind of worsen the situation. So that's why using rate limit headers will give you more throughput in the same time window compared to not using them. All right, time for some demo. I'm looking at the chat. If there's anything specific, Vesa, then I can handle that, but I don't see anything.
No, nothing too specific.
Nothing special.
Let's do the demo, and we can follow up afterwards. Yep.
Yep. All right. So demo. Visual Studio over here. And actually, let me do one more thing. I'm going to paste some links. So in the chat, you see a link to the SharePoint throttling page, which is the basic documentation, and also to the sample. So you can, the code I'm showing here, you can just follow along and already look at the code there and play around. The sample to test this is relatively simple. What it does is it allows you to kick off a number of threads, like 5, and decide whether you want to use rate limit headers, yes or no. So you can really experiment and play with it and learn. That's the goal behind. To use the application, you need to have an Azure application configured, which is done here already. Is in the documentation how to configure things, but in this case, we set up an application with a certificate because we're using application permissions. I'm not going into details of that, so just check out documentation to learn more on how to do that. Then the key thing in the application is this HTTP client and throttling handler. Now, to explain that a bit better, I'm going to go back over here and go to this slide. So in .NET, HTTP client is the core class that you use to make a HTTP request, to call something, to call SharePoint, for example. And in the HTTP client model, there's a concept called delegating handlers, which allow you to kind of extend and plug in a functionality inside the HTTP client. So in our demo, we built a delegating handler called throttling handler that will handle the throttling, but also will handle the rate limiting. So using the rate limiter.cs class. So let's have a peek at both of these classes. Going back to the code. So here we have our HTTP client, and you see that we are kind of passing in a throttling handler. Going into the throttling handler, the main thing is that we have an override of the send async. So when you make a request, you do call the send async method on the HTTP client. And in here, we have a loop. And in this loop, let me go to the bottom, we do the request. So we call SharePoint, call a REST API, call a Graph API. We call an API. We get the response. And if we're not throttled, then we're good. We return the response. Otherwise, we clone the request and try again. So because this is a loop. So this code shows you how to handle throttling and how to retry. Now the key part of this demo is the rate limiting. And for the rate limiting, the thing is that when you do a request, at a certain point in your response, you see those rate limit headers appearing. So your code needs to look at the responses coming in and store the information that comes in the response. And then for the next request, you have to then validate, like, can I make this request or should I wait? So the first part is looking at the response and possibly storing rate limit headers. That's done using this using the rate limiter class and the update window method. So let's go over there. And this method is very simple. It will check the response headers. Are those headers there? So the limit remaining reset headers. And if they're there, they're just stored. And that's it. So we have a thread safe way to read those headers and store them. So fairly basic. Going back. In here, before we actually make the request, so we imagine that our last request gave us some rate limit headers and we store them. The next request we want to make, we want to look at those rate limit headers and decide whether we can continue, yes or no. And that's done using the wait async method, again in the rate limiter class. And this one, you see us here looking at the data we collected and then decide whether we should wait, have a delay or not. In this case, in the sample, you can tune the delay based upon the minimum capacity left. So what this means is that whenever we have 10% of resource units left or less than 10%, then we'll wait. If not, we continue. And this figure, it may depend on your application. If you do lots of parallel threads, you might want to put this a bit lower. If you have just 2 threads, you can maybe put it on 5 or even less. Good. Going back over here, we explain those things. So the HTTP client can be used to make a Microsoft Graph call, a SharePoint REST call. For CSOM, it's a bit special there to make a CSOM call. Well, you can do SharePoint CSOM call using our CSOM libraries, all good. But to get the response and look at the response headers, you need to plug in a custom web request executor factory, which then can use this HTTP client. So this same HTTP client is used for making graph calls, REST calls, and CSOM calls. Right, let's go back to my demo class, and we explained this. We explained that now here we are starting a number of parallel threads, and each thread does some work. In this case, in a loop, we are calling REST, graph, and CSOM, and then we just get a response back. So it's a fairly simple application doing 3 calls. Now, let me just, to start, use it with rate limit headers on 5 threads. So I press F5, the application starts to run. Yes, that's a little annoying thingy there. Okay, let me make this bigger so you can see more. And what you see now is that the application started. We have those 5 threads that we kicked off. Each of those threads is doing calls, doing a REST call, graph call, and a CSOM call. And at a certain point, you will see this application getting rate limit headers. They start to appear when we are at the 80% mark. And then if you'll then see how they are kind of processed and how the application will wait. So we have to wait like 20 seconds more because we have this 1 minute window that we use for the resource unit checking. And here you see already rate limit headers appearing. You see for CSOM, for graph, for REST. So it doesn't matter which API you use, you get the same rate limit headers. And you see the reset, like so it's still good. We're not having to wait yet because I configured this like only wait once we are at the less than 10%, which just starts to happen right now. So you see this graph request is delayed for 4 seconds. Another CSOM request delayed for 8 seconds. So you see how it works. So now we're kind of slowing down a little bit. And once this slowdown is done, once we're in a new minute, we can kind of speed up again and then slow down again. And this is how this kind of works with rate limit headers. Now I'm going to stop this application and let's try again without using rate limit headers and see what will be the difference. So same application, but now we just ignore rate limit headers. Pressing F5. Let's zoom in a little bit. So it starts the same. You get the same speed in the beginning. Application starts to issue the SharePoint REST, CSOM, and Microsoft Graph calls. And at a certain point, we'll see a different behavior. Looking at the chat. There's too many messages to really see the questions, if there are questions. Any questions, Vesa, that I need to address?
I think people are answering the questions. There's a good chat going on the implementation, and people are being impressed on seeing this live. This is really cool.
Okay, good. Thanks. We're getting close to the 1 minute time window. Remember that we had that 1 minute, and we're pushing hard, and now you see throttling happening. Now you might say, yeah, whatever, throttling is good. Well, I'll just wait, but look at the wait times. 30 seconds, 39, 40, 43, 42. So when you get throttled, you also tend to see like longer wait times. The retry after header is telling you to wait longer, which really means this application gets to like a full stop. And once the minute is kind of over and all the wait times are gone, we'll kick off again and we start going. But this is not really that efficient compared to using the rate limit headers. So that's why we have those headers. No point in keeping this running. I'm going to close it. Looking at the time, okay, we have a couple of minutes. Let's go back to slides and let's go to some Q&A. Common questions that we get when talking to customers, and I see this. Are exceptions possible? The answer is no. Even first party uses the same logic and the same rules for most parts. The user agent string, what about that thing? Because we initially said like you have to specify user agent and we can give you exceptions. A long time ago that was. Today, no exceptions anymore. User agent, not required, but if you specify it, it's fine because it helps support and kind of investigate and understand which application, which version of an application is making a particular request. So if you have it in there, just leave it in, it's good. An interesting one. Can I use multiple Azure applications? You just told me that one application gets so many resource units. What if my application just uses 5 Azure applications and load balances across those? Is that fine? The answer is no, that's not fine. Simply because you will start to exhaust the complete tenant, and that will impact all applications inside the tenant. So if you do this behavior, you will see that things start to fall down, and then your customer will not be happy because multiple applications will get heavily throttled or even blocked at a certain point if this keeps on going. So definitely a no-go. Should I use a service user with delegated permissions versus application permissions? Again, the answer there is no, bad idea. Because a service user is a user. And remember that we had that left column when you had the funnel, we also check how many requests a user does. And if you use a service user, you're likely to kind of run over those limits and get throttled. So if your scenario is a backend scenario, then you just use application permissions and not the service user concept. Last ones. My app needs to read all content and stay up to date. So I have an application that needs to monitor all files in all libraries across all sites in my tenant. Can I do that? Yes, that's possible. We have a concept called scanguidance, which explains how to do that. But it comes down to the fact that you do initial kind of crawling of the content that you need, and then you use subscriptions and Delta queries to update your copy of the content. So you do scan everything just once, and then you do Delta updates. So, and using this pattern, you can really process a lot of content in your application while not getting too much throttling. And the last one, load testing. Is this a good idea? Like many of these, the answer is no. Please don't do that because you will get throttled and your test results don't make much sense because you get throttled. And here are the resources that I already talked about and share them in the chat window. With
now,
that,
before you
yes.
close, there was 2 questions which I wanted to ask. Is all of this automatic in the PnP PowerShell and PnP Core SDK? Was the specific questions in and what about Graph SDKs? Is all of this taking into account in those?
Really good question. For the PnP side, in the Core SDK, this is implemented but not turned on by default. So there's a configuration option allowing you to just turn it on, and then you can say like I want to apply weighting when we are at 10% capacity left or 15%. So you can choose that, like in this demo. So that's there in core SDK. The framework and PowerShell is not on by default and not there yet. So we still have some work to do to kind of integrate that fully into the SDKs. And the same applies for the graph SDKs. So today they don't officially have this built in. You can start to add this yourself, but it's not natively built into the SDKs today.
Cool. Really, really cool and awesome demo. I shared the sample link to the sample in the chat already. We'll put it in the summary blog post and all of that. So, and a great work on the sample as well. The documentation on that is awesome. It's for everybody to understand what's available and how things work. So thank you, Bert, on that.
Thank you.
Really awesome.